Good day everyone, my name is Joemarie A from BS Ed Math 2A. I'm the second reporter of our group and our topic is all about Nano World. So this is the continuation of our report on the Nano World. What is Nano World? First, we need to define nanotechnology and nanoscience. Nanotechnology refers to the branch of science and engineering devoted to designing, producing, and using structures, devices, and systems by manipulating atoms and molecules at nanoscale. So, ang nanotechnology ay tumutukoy sa sangay ng science at engineering na nakatuon sa pagdidisenyo, paggawa at paggamit ng mga estruktura, kagamitan at sistema sa pamamagitan ng pagmamanipula ng mga atom at molecule sa nanoscale. Nanoscience combines science, engineering, and technology to study matters and processes at the nanoscale. The nanoscale is based on the nanometer, a unit of length equivalent to 1 billion of a meter. So, ito ay pagsasama ng siyensya, engineering at teknolohiya upang pag-aralan ang mga bagay at proseso sa nanoscale. Ang nanoscale ay nakabatay sa nanometer, isang unit ng haba na katumbas ng 1 bilyon ng 1 metro. To further understand the nano world, here are presented important personages who have contributed to the growth and the study of the nano world. So, upang mas tubos natin maunawaan ang nano world, dito nakapresenta yung mga importanteng tao na nag-contribute or umambag sa paglago ng pag-aaral ng nano world. Richard Feynman, the retroactive rediscovery of Feynman's plenty of room, gave nanotechnology a package history that provided an early date of December 1959, plus a connection to the charisma and genius of Richard Feynman, Feynman's stature as a Nobel laureate, and as an iconic figure in the 20th century science, surely helped advocates of nanotechnology and provided a valuable intellectual link to the past. Si Richard Feynman ay isang American theoretical physicist na nag-publish ng libro na may pamagat na Plenty of Room na itinatag noong December 29, 1959. So ito ay nagbigay ng nakabalot na kasaysayan sa pag-aaral ng nanotechnology. Eric Drexler, his paper on the nanosystem, molecular machinery, manufacturing, and computation received the Association of American Publishers Award for Best Computer Science Book of 1992. Drexler founded the Forsyth Institute in 1986 with the mission of preparing for nanotechnology. So, ang kanyang papel sa nanosystem, molecular machinery, manufacturing at computation ay nakatanggap ng Association of American Publishers Award para sa Best Computer Science Book sa taong 1992. Itinatag ni Drexler ang Forsyth Institute noong 1986 na may mission na paghahanda para sa nanotechnology. Nanotechnology and nanoscience got a boost in the early 1980s with two major developments, the birth of cluster science and the invention of scanning tunneling microscope or STM. These developments led to the discovery of polarness in 1985 and structural assignment of carbon nanotubes a few years later. So noong panahong 1980s, mas lumago ang nanotechnology at nanoscience sa paglikha ng cluster science at ng STM o ang scanning tunneling microscope. Itong mga pag-unlad ay siyang nagsimula sa pagtuklas ng polarness sa panahong 1985 at sa pagkabuo ng carbon nanotubes pagkalipas ng ilang taon. Gerd Beinig and Heinrich Roher, the scanning tunneling microscope, an instrument for imaging surfaces at the atomic level, was developed in 1981 by Gerd Beinig and Heinrich Roher at IBM Zurich Research Laboratory for which they were awarded the Nobel Prize in Physics in 1986. Ang scanning tunneling microscope ay isang instrumento para sa paglalarawan ng isang bagay sa atomic level. Ito ay binuo noong 1981 nina Gerd Binig at Heinrich Roher sa IBM Zurich Research Laboratory kung saan sila ay ginawaran ng Nobel Prize sa Physics noong 1986. Calvin Quate and Christoph Gerber invented the first atomic force microscope or AFM in 1986. The first commercially available atomic force microscope was introduced in 1989. Inimbento nina Calvin Quate at Christoph Gerber ang unang atomic force microscope noong 1986. Ang unang komersyal na paggamit ng atomic force microscope or AFM ay pinakilala noong 1989, 3 taon pagkatapos nito maimbento. IBM researcher Don Igler was the first to manipulate atoms using a scanning tunneling microscope in 1989. He used 35 xenon atoms to spell out the IBM logo. He shared the 2010 Kavli Prize in Nanoscience for this work. Ang mananaliksik na si Don Igler ay siyang kauna-unahang nagmanipula ng atom gamit ng STM or ang Scanning Tunneling Microscope noong 1988. Ibinahagi niya ang kanyang 2010 Kavli Prize sa Nanoscience para sa gawaing ito. Initial commercial applications in the early 2000s saw the beginnings of the use of nanotechnology in the commercial products, although most applications are limited to the bulk use of passive nanomaterials. Examples include titanium dioxide and zinc oxide, nanoparticles in sunscreen, cosmetics, and some food products. Ang halimbawa ng paggamit natin ng nanotechnology sa ating mga produkto ay ang paggamit ng mga nanoparticles tulad ng titanium dioxide at zinc oxide, ang mga sangkap na nilalaman ng ating mga sunscreens, cosmetics, at food products. Silver nanoparticles in food packaging, clothing, disinfectants, and household appliances such as silver nano, carbon nanotubes for stain-resistant textiles. Sa silver nanoparticles naman, sa mga food packaging tulad ng mga dilata, sa ating mga damit na may antimicrobial, mga kagamitan sa loob ng bahay tulad ng refrigerator, TV, washing machine, disinfectants. Ito ay mabisang antibacterial na ating ginagamit tulad ng mga alcohol, toothpaste at iba pang cleaning products. Kabilang rin dito ang carbon nanotubes para sa mga stain-resistant na tela. Cerium oxide as a fuel catalyst. Ang cerium oxide ay nagsisilbing katalista ng gasolina upang mas magiging epektibo ito para sa ating mga sasakyan. As of March 10, 2011, the Project on Emerging Nanotechnologies estimated that over 1,300 manufacturer-identified nanotech products are publicly available, with new ones hitting the market at a pace 3 to 4 per week. So here are the potential uses of nanotechnology and nanoscience. The Joint Center for Bioethics in Canada ranked potential uses of nanoscience and nanotechnologies with respect to development. Here are the top 10 uses as follows according to BBC News of 2005. So first, we have energy production, conservation and storage, enhancement of agricultural productivity, treatment and remediation of water, screening and diagnosing diseases, system for drug delivery, processing and storing food, controlling air pollution, construction, monitoring health, and detecting and controlling pests. The nano world is perhaps the fastest growing world in the 21st century. Global competitions among nations in nanotechnology research, development, and marketing is on the rise. Advantages of nanotechnologies towards improving the quality of life are many and are felt by humankind. Whether the nanoworld holds any solution for problem faced by science education is a critical question which must be addressed in its entirety. However, disadvantages of nanotechnology, especially related to human health and the environment, are only beginning to surface, raising serious concerns. Systematic explorations, characterization, organization, and regulation of the nanoworld are warranted to make the best use of nanoscience and nanotechnology. The nanoworld will continue to influence science and technology. That's all for our report on the nanoworld. Thank you and have a good day.